I think if someone wants to give a talk on how to set up projectors next time, that would be a good one, like really popular.
Setting the time on VCRs.
Sorry, 800 by 600,
Also
75 hertz.
It'll take a second. It'll go there.
Here we go. Come on, everybody.
It's not a real meetup unless there's tech issues.
Okay, so gadget. If we go to gadget.new here, we're going to see UI. I'm going to say I'm going to build a web app. We'll say, well, actually, I don't care. Say I don't want any auth. Blah 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 blah. Continue. We'll give it a name. We'll say Ottawa Systems demo. Hit confirm, and so this is like live, sort of in production on the web. What this does is it goes off and makes me an app. I get my own like little URL for my app, Ottawa Systems demo.gadget.app. And behind the scenes, Gadget's provisioning me a back-end, front-end database to store stuff, and then duplicating that in a development environment and a production environment. So if I just look over here, I get this like file system where I can like manage my application. I have a web folder for my front end, some React stuff, an API folder for my back end, my like URL here. I can like preview my app in the editor. Like here, it's like loading up, you know, beginning the stuff. Behind the scenes, this is like cold booting a server where my app's gonna run. It started like Vite, it did the front end stuff, it installed all my dependencies, like hooray! And like, to be completely frank, this is the kind of value that our customers get from us. It's that they didn't have to like mess around with a local development environment. They didn't have to get Node running. They didn't have to like wire up a database. They didn't have to fight through dependency hell. Like it's just kind of there. It isn't infinitely powerful, right? Like you couldn't build, say, Anubis with it. It's not a reverse proxy infrastructure sort of component. It's for building web apps. And so that's what, yeah. So there's a few kind of like corollaries or like things that come out of this. Let's go back to this. Nice. The first is that development environment thing. So it's kind of like Replit, if you've ever used it, or Code Sandbox, or Gitpod, or whatever. We're both the like place where the development happens, where you like type, save, refresh, reload, and the place where production happens, where you need many instances and it's elastic and they kind of optimize for throughput. And the thing with the development requirement is that it is not suitable to use production style tooling to power it. So if you had to like save, build a Docker container, ship a Docker container, reload the Docker container for every like save refresh cycle, you'd like get very frustrated very quickly, right? So we can't use the normal, say like Google Cloud Run or AWS Lambda or whatever to host these development environments. We need something where you can like type, save, and then something reloads like immediately, and you get to kind of iterate on your thing the way you'd expect. Also, I guess maybe we made this up, maybe we didn't, but by virtue of it being a web app, people kind of expect it to be multiplayer these days, where it's like, you and I can both go to the Gadget app and type, and I see your cursor and you see mine, and it's like Google Docs. In addition to all those fun dev requirements, we have, oh fuck, I'm sorry. Over here. There we go. We have the normal prod requirements as well, right? Like the things that Lambda or Google Cloud Run or whatever would be good at, which is we want elasticity, we don't want to pay for resources we're not using, we want to kind of get the ability to deploy new versions really easily, but have the confidence that they're not busted when they go out, that kind of thing. So yeah. Why not Lambda Cloud Run? Because of the bundle step. And then the other thing is all these apps are Node apps. So they, like Node.js is the kind of lingua franca of the, at least Shopify app development ecosystem, which is where we make the majority of our money. And Node's like so needy. It's so needy. The first thing is that it's like module resolution algorithm. Like when you import something, it spams stat syscalls, like absolutely spams. It's horribly, horribly inefficient, but it like needs to check every parent folder for a given file every time you import a file until it finds it. Yeah, it's really bad. Among other things. And then the other reason why we didn't want to use like Lambda or Cloud Run to power our stuff is because we want to make the money from the hosting. Like that's kind of our raison d'etre as a company, is like help developers do stuff. If we use those things, those are like Google's high margin products where they overcompress everything and overcommit everything onto boxes. I want to do that to my customers so that I get to make the margin. You know what I mean? Of course, within reason, but yeah. So in order to support that, specifically that development hot reloading use case where I like type, I hit save, I see like an instant refresh and I can like work on my application, we decided that we needed mutable runtime production environments. That were going to be naughty, and we're going to change what's on disk in the Docker container or whatever the runtime artifact is, like over time a lot. No rebuilding new artifacts. Like, yeah, maybe we have a base artifact, that kind of like we build as a platform, like once in a blue moon, but otherwise when a user does a save reload cycle, it changes in there. And then the other thing that makes all this hard is node modules. I don't know if you see this meme. This meme is my life. It's not funny to me. It's death. It is hurtful.
It's a bug. It's only in megs.
It's like genuinely, yes. This was a fresh package or a fresh app. This is the size of the app I just created. I did this yesterday. It's 164 megs of dependencies, and the problem with this is that it's both large in bytes and large in files. There's like 70,000 files in there, which is like it's just stupid, right? So there's like a weird dev prod sort of difference there, right? You don't necessarily need every file from every dependency in prod, but we'll get to that in a minute. So these are the requirements that we had when we went searching for like a way to manage these files. We needed super fast cold starts, right? Like nobody wants slow. They want their prod to be fast. They also want their dev to be fast. They don't care as much. And like all the big clouds have the benchmark wars for their cold start times, so it's like we can't just be 10x worse. We have to support Node really well with the module import pathology and the giant Node modules pathology. We need some degree of multiplayer where it's like not just one machine with one writer. There's like gadget the platform is writing at the same time as the developer is writing, or the developer's like has two tabs open or whatever. And then for us, we're a multi-tenant platform. We're not deploying like one server per user. We need efficient server usage over time. Yeah. So some might ask, why not Git? Git seems like it could do this, right? It's a distributed file system manager. If you git add .node modules folder on this ridiculously fast computer, it takes 6 seconds. That's because it's shawing all the files and doing all this stuff. Git has a shit ton of optimization put into it, and it still takes 6 seconds, right? If you like change a bit of stuff and you do git status, it's like quite a bit faster. Then if you like happen to change the updated at of a bunch of files, it gets way slower again because it has to rehash everything and compare. So Git is built for managing like human scale artifacts, if you ask me, not computer scale artifacts, right? Like we try not to vendor our dependencies in the Git repo, or we pay a huge upfront clone time if we do. And that's okay if you're like, I'm the monorepo person, I love vendoring my dependencies, like I'm gonna do that once a year when I get a new computer. For us, that's our cold start time. Like we absolutely can't. So that we had to write off Git even though we wanted to use it, but it's got a lot of what we needed. What we did start with was NFS. Yeah. Thank you. Yeah. That was dumb. This is like the prototype stage, to be fair, but still. So it's really easy to integrate into K8s. It's really easy to like use a CSI driver or whatever to say like present an NFS or an NFS subvolume to a pod. Like awesome. The problem is that stat nodule resolution algorithm that like asks about every folder has a network round trip now to the NFS server every time. So it's like ungodly slow, like absolute non-starter. And like, would you want to do dev on an NFS share? No, right? Like we're a company trying to sell a product. You can't do that. The other thing is it's really expensive. I didn't know that when I first started it, but like Google charges an order of magnitude times 2 more than Google Cloud Storage for it. So that sucks. Then another thing people always ask me is why not like cloud storage? Like, can't we just use the infinite cloud in the sky to store all this stuff? And I'm like, yeah, that'd be great, but it's not enough on its own. That's kind of the problem. Like, if you're going to put the files in GCS, you got to sync them in there somehow and then download them out of there on every cold start. and you need to like auth that somehow. Like I'm not giving out the GCS bucket keys to all these like individual apps. I'm also needing to do multi-tenant auth, or sorry, limit enforcement. It's like you only get 600 megs if you're on the free plan or whatever. So it's kind of, it'd be GCS plus a whole other thing that we'd have to build. And then, yeah, no atomic commit, so we didn't go that route. When we zoomed in on the like performance issue, we started to see like a pattern, which is that every layer of virtualization really exacerbates nodes' behavior specifically. It's that if we want node to be fast, our solution space gets a lot more constrained because we have to deal with this like, I don't know, 50, 100,000 stat calls every process start. So this is like the original architecture we're thinking about. Google Cloud persistent disks for like volumes, just like floating around in K8s like you might expect. Maybe a fancy fuse daemon that's like caching on the node or doing some kind of nice sharing of dependencies so that we're not like restoring every single thing every time. Google has a really awesome sandboxing product called gvisor, but the gvisor like virtualization that gives me kind of peace of mind as a platform operator, adds a lot of overhead and is very slow, and then Node's not going to change, right? Node's just going to work the way it is, so it's like that whole stack under there has to support it. So we decided this was like also a non-starter, that we wanted a local disk, and that was like the only way. So if we constrained ourselves to saying like Node has to talk to NVMe that's on the box, now it becomes something that looks more like a file sync problem than a file system problem, if that makes sense. We just say like get everything there and then let it run as if it's like normal ext4 or whatever. And that's what we did. We built a file syncing server called data logger. That's German for file storage. And it sort of sits next to the pod as opposed to, or sometimes in it also, but and it just writes files to disk. And that's, I don't know if like you would dispute that's a file system or not. To me it's a file system because it has to be a system to store files. But it like moreover it has all the same like semantic challenges, right? Like it has to get the mode right. It has to be symlink aware. It has to have garbage collection, like for all the cruft that gets generated over time. But we're just not actually serving the files, if that makes sense. We're like letting Linux do that because it's good at it. So this is like the basic architecture of the thing. We have the server, which is like the kind of source of truth, like broker in the middle, the web editor that we saw a minute ago, or the other tools that let you change your files with Gadget, like push writes at the server. It brokers who the winner is and does conflict resolution, all that stuff. Oh my God, Postgres is where we store the stuff. Who would have guessed? And then all the kind of tenants, like the individual pods that are serving requests for a Gadget app, they sort of fish what they need out of the data logger server. And there's like a nice little gRPC protocol that we made up to do that. The basic way that it works is as just a userland binary that you run that takes a folder from nothing to the file system that you want. So if you have like, we're inside a production pod right now, if I have my like app.dir where I want to cold start and I don't have anything right now, I run data logger client rebuild, tell it which tenant I am, what version I want to download stuff for, what directory to store it in, where to find a cache. It goes off and does its thing, and it writes all this stuff to disk. It does the symlinks, it does the file, the mode, it does limit enforcement, all the file system stuff. And then for that hot reload loop we were talking about, where it's like I type, I hit save, I want my app to refresh, data logger knows about this version concept and what has changed between individual versions. So I was at 15, I changed my logo, I want to get to 16, I say rebuild to 16, and it knows, it's able to kind of exchange with the server, I'm at 15, I want to go to 16, what's new since then? Download it and do that. These are like monotonic integers as opposed to git SHAs, but it's like pretty much the same as git, where it's like, what's new, gimme, and like write it to disk. So, actually before I like dive in further, any questions? Does that make sense? Is that clear? Yeah.
Did you say that you you store your node modules in the Postgres?
Mm-hmm.
All of them, like all the
Mm-hmm.
mode and some.
Just you wait. I'm excited. I'm glad that you noticed that because yes.
Do you still use gvisor?
Yeah, kinda. We at the end, I have a long rant I could go on about that.
Looking forward.
Yeah. So we talked about the basic architecture. What I want to talk about is our performance targets and if they're even attainable or like how we might get there. So for the cold start, like in production, this is like, this is our users being like, my app is at 0 instances, I get a request, I want my end user to not have to like wait for 10 seconds while Harry's bad system downloads all the node modules, like gimme fast. So we said we wanted like a 200 millisecond P50 for cold start, and then there's like giant apps that include like gigabyte sized TensorFlow models. They can take a bit longer. I'm okay with that. But yeah, that's a common node module.
Are those also in the?
Yep. And then again, the apps have 75,000 individual files in that node modules directory. Like I don't know, median apps 200 megs of those files. So that just sucks because it's like a lot. It's like a high constant number of file write operations and a semi-high number of bytes to write into those files. And then we have very high tenant diversity, like many different apps built with Gadget, but remarkably low individual file diversity. That they all use the same 100 node modules times 10 versions per. That's still only 1,000 unique node modules. You know, it's not crazy. And then right now we're not bundling for production, which if you're a JS head is terrifying. It's so unpleasant. Yeah. And then in dev, much less sensitive to the cold start time because like people kind of it's like the equivalent of opening your computer. You know what I mean? You sort of like start your work for the day. You do it once. If it's just running the whole time, you're chilling. But the thing that we are very sensitive to is that kind of like small update latency. Type, save, refresh. We want to hit like as fast as local development, or else we're worse and no one will use us. So that budget's very tight. We said 60 milliseconds P50, 200 milliseconds P99. Yeah, and then yeah, definitely not bundling. So how the fuck are we going to do that? We said caching. I think the only option is to exploit that lack of file diversity to put most of what's needed in place already. It is kind of a saving grace for us that the high volume, both in files and bytes thing, is the dependencies, not the apps themselves, right? It's not bespoke content. Like, yes, those apps are big, but they make like, I don't know, 50, 100 files, and it's like 100K of code, you know? Like, that's pretty easy to just download, like, anew every time. It's the massive black hole of node modules that's the problem. And the good news is, as a platform, we can actually provide an even better experience to our users than they might get if they go somewhere else by like special casing those node modules and putting them on the like pre-warmed compute already. So if we have our Kate's fleet, we have these big nodes, we like download, like pre-download and have all the node modules handy, they're gonna get a faster cold start from Gadget than they would from like Lambda or whatever, because it's like right fucking there on the disk already, you know? Yeah, and then the next kind of final problem is just the ON file operations beyond just getting the bytes locally. But does that make sense? Questions? Thoughts? So this is what the Postgres tables look like. It's not just a like row with like a project 1 file path content. It's content addressable. Same as Git. Stole it mercilessly. So we have a like untenantized table of hash to content, and then a tenantized table that's kind of a pointer that's just the file system metadata, like what's the mode, what's the path for the content. So we get really nice deduping, such that our database, I don't know, it's like 600 gigs or something. And then for node modules specifically, we don't actually just store the byte of every file, we store a tar gzip of the whole node module. So we just stash like a compressed tarball in there, and that way we're not like managing all the metadata for all the files. Like the node module at a version is kind of immutable. They don't, like it's like low-dash at version 1 has the files it's going to have. It's never going to have any other files. So treating that as one kind of atomic artifact, especially compressed, it's quite nice. And then, yeah, one other sneaky thing we did is track kind of object liveness in the file system using these like start and stop columns. So instead of just saying, this is the current file system, we have this sort of version history of what all the files that were live at any time were, and that's what powers that like from 15 to 16 thing. We can do these pretty efficient Postgres queries to ask what's new. And it does all the heavy lifting for us. Like I think our max query latency on that, it's usually like 100, 150 milliseconds if it's a shared buffer miss. So it's like, I was surprised at that when we first messed around with it. So this is like the server-side representation, right? This is in the this piece here. We still have this problem of like making it real on the node itself. So we are heavy users of K8s, just for our own sanity. And the way that it works is we have the local NVMe, and we use GCP, so this is just like GCP nodes with local SSD involved. They handily RAID them for you if you ask for more than one, so we just have a big one, it's nice. And then we have a bunch of different apps. These are heterogeneous, they could be like different tenants, and we basically give them an empty dir volume. And we have our like userland binary to manage the files in that empty dir volume. The big innovation that we did recently was to switch from just having like the pod here have a local cache within it, like in the Docker container, in that base SHA, to moving the cache out onto the node itself so that we can like 10, 100x the size of it and only have one of it. The only reason it was in here was for simplicity before, but now what we've done is kind of like pre-deployed those tar gzips onto the nodes themselves so that they're like handy. There's still always novel content for each app where we have to go get like the specific code that wasn't a cache hit. And we made a rule which is only node modules go in the cache right now, just because we're afraid of the like security concerns of like, or like side channel attacks of like, I found this file really quickly, that must mean someone else is using it, or I don't know. I'm sure there's a way to do it, I didn't want to have to figure it out. Okay, sorry, before, this is going to get deeper and more intense, so I just want to make sure, does that make sense? Checks out? Questions? Thoughts? Broad brush strokes? Okay.
Some concern.
Me too, Leslie, me too. Okay, so, let's say we are going down this path and we have 2 pods, and we have the 2 pod file systems. They're different apps, so they need different file systems. We're on the same Kubernetes host, so we have our like kubelet here. We have our cached CSI driver, which is like implementing this whole scheme host, and then we have this like golden copy of the cache. We call the golden copy that like prefetched, not app-specific stash for all the stuff. Those same hashes you saw in the content addressable store are the hashes we address the cache by. That makes it very easy to know like what we have and what we don't have. And the trick, or like the whole challenge, is how do we take this cache soup and like present it in this shape that Node wants, right? Node doesn't know what these caches mean, and it has a very specific need for the way the Node modules directory is structured, and like the cache has to support storing low-dash at every version, but in the Node modules folder, it's like node modules / low-dash, no version number at all. And so there's this like mapping that has to happen between the two. That is basically the epic, huge, annoying problem with all of this. Right, sorry, I should have moved to this slide already. So those caches, in the case of the tar gzips, are folders, or they're extracted tarballs with folders of stuff, or if we ever did single file caching, they would just actually be the file itself. And so yeah, this is if you're unfamiliar with Node, this is what a Node modules folder looks like and what we have to assemble. How we do it today is with overlayfs. And it sucks, and I'll explain why. What I would love from y'all is some feedback on my plan for how to make it better. Yeah, I have a plan, but I'm just kind of curious, like, what your take on it is. Because I think it's going to work, but I'm curious if you see a different option or whatnot. So yeah, this is very selfish talk for me. So approach number one, what we're doing in production today is we use an overlay. And the reason why we use an overlay is specifically to avoid any chance of cache corruption, right? We are a multi-tenant platform with attackers who build apps who want to, for lack of a better word, fuck us. And so we need to ensure that if they get a cached node module mounted into the application, they're not able to corrupt the golden copy that gets given to all the other apps, right? That's like worst case scenario for us. So we need a way to present the cache in a high performance manner, but a way to ensure that any writes are kind of latched for them and not propagated downwards. So originally we were really hoping we could get away with hard links, but we cannot. Hard links are the same inode. Any writes to one are reflected by all the others, no worky. We were also hoping we could get away with symlinks or some other sort of indirection thing. Node hates symlinks. You can't do symlinks in the node modules folder for really, really stupid reasons. And even then, without complicated interception of it, it wouldn't have fixed it. So what we do is a combination of an overlay for safety and hard links for mapping. So we take the cache, we overlay it into the pod, which gets us our safety, but no mapping. And then that userland binary, that data logger-client rebuild operation, assembles the right shape of the node modules by hard linking out of the cache. You're nodding, Chris, but it sucks. Yeah.
Do people write into the node modules?
Yes.
What are they doing?
Yarn install
Oh.
or yarn upgrade, whatever.
Okay.
Right? It's development, so they have to be able to change
But they
it.
don't actually change the files.
Yarn does, or they could too, right? Let's say we were Lambda. No, they would never change the files, right? It's any new version is a new Lambda artifact. For us, we have to support the use case of I want to try out a new version on a branch. I want to downgrade because I've noticed a bug.
Yeah.
So it's
But the actual files that you cache would be into, right? It would be right? They would try to maybe replace the same file with a different. You know what I mean?
I do know what you mean. So Yarn.
Not expressing that well.
No, I know, yeah. Yarn, the specific package manager that most of our apps use, sometimes it replaces the file, and
Okay.
sometimes it
That's
doesn't.
great.
In our case, though, we have to be prepared for the eventuality that they'll make a write, so we have to do it in this manner where, if whoops. And to your point, the pod's copy of the cache would be corrupted if someone made a write over here, because it's a hard link, so it's the same inode, so it's the same file. So they can corrupt their own cache, and I don't care. So the reasons why this is good is huge cache, a lot less downloaded from the data logger server when we're cold starting, because we can make this big and that's a money knob. O1 mounting of the cache into the pod, which is awesome, but ON hard links. And at 70,000, that adds up. It specifically adds up to more than 200 milliseconds. We have not reached our performance target. We've spent a lot of time on this one function in data logger that is the hard link hot loop. We tried all sorts of stuff. There's a parallel file system walker in Go that's really nice. We tried IOU ring, and the interfaces for that in Go really suck. So I don't know if it's possible to do 70,000 hard links in 200 milliseconds, but I haven't found any system that does it. I think the bottleneck is actually the file system's metadata layer. It's XT4 has some locks in its internal stuff that we bump up against, and it kind of checks out. So
Have you tried ZFS?
we haven't, but Butter is in our future.
Butter might work, yeah. Also try ZFS.
Yes.
Yeah. Interesting.
ZFS does some crazy multi-threaded stuff. I also know that XFS is also heavily multi-threaded, so go with the higher letters in the alphabet.
Yeah. So the other issue is this really interesting behavior of overlay that I did not know about when I started down this path, which is when you hard link a file that's on an overlay, overlay needs to guarantee that the kind of is everybody familiar with upper and lower? Probably not. Let me say. So an overlay FS is it's a file system built into the Linux kernel, and its job is to take a lower file system and leave it unchanged, and an upper file system, which will also, that can be changed, and smoosh them together and present it as one on top. And what that allows you to do is kind of like shadow lower stuff that you wish to leave unchanged with higher stuff that you're okay with changing. It is the technology that allows Docker layering, or that they use to implement Docker layering, where you can shadow more than once and kind of build up this file system of these immutable bits and ensure that nothing changed. So overlay kind of like intercepts writes, and it's like, is this a file that already exists on the upper? Okay, I'll keep writing to upper. Oh, this is a file on the lower. I will copy it to the upper and then begin mutating it. So when you hard link a file on an overlayfs, it forces a copy from the lower to the upper. And that's because the hard link is the same inode, and so the one up here on the mount needs to point to something that's okay to mutate. So it goes. So for me, in my genius move here, when I said hard link to do the mapping, what it actually is 70,000 hard links and 70,000 file copies from the lower to the upper. Sad. Still faster, weirdly, than a small cache, but still sad. Sorry, someone had a question or a thought over there. As far as I know, this isn't a bit like a thing that Overlay has chosen to do to just tank performance in this situation. I don't think there's any other option for it. I think it has to when you do a hard link. If we could do a different kind of link, I think it would be different. So, Overlay approach 2. This is what I was working on yesterday. How many people are familiar with ref links? Nice, we got one. So, lore and legend speak of futuristic file systems with a link type that sits in between hard link and symlink, called a ref link. XFS supports this, ButterFS supports this, and what it is a special thing that when you have a file system that works with like copy on write, like they have this sort of block deduping fancy stuff like under the hood, you can create what looks like a hard link, and like to any userland programs is straight up two totally separate files, but they share the underlying blocks, and the userland program can't detect that. It doesn't know that, but the file system just like manages it for you. So if you like mess around with the file, you write at byte offset 10, it'll like duplicate that block, but leave the other ones unduplicated, and you live in, great joy. So, like, I find the tools of hard links and symlinks insufficient for this problem. I want to reach for this other thing, and I haven't 100% proved it to myself, but in some small prototypes I proved it kind of works, which is if you use ref links instead of hard links, you don't get that undesirable file copy up to the upper thing. You just kind of get a new inode up here, pointing to a different inode down there, but shared blocks, so there's no copying, which is really nice. We run in GCP, and I'm lazy, and I have an infrastructure team of 3 other people, so like I don't really want to be messing around with custom file systems on all our on our Kate's nodes and stuff, but like I think I have to. So this is what we're going to do next, and see if it works. So we're back in the world of still ON operations, but at least they're just metadata syscalls instead of the file copies also. Yes.
Maybe I'll have my comment for later. I'm just really happy that you mentioned you want to get involved in messing with file systems.
Yeah. I'm deep, if you can tell. I'm deep. So yeah, same whole scheme, same everything, except dashed lines here for separate items. Overlay approach 3, the promised land. Oh, we're getting close.
Yeah, 5 minutes.
Okay, shit. Let me go fast. I think we're almost done. Great. The ON thing there bums me out. The fact that we have to do, like if someone adds more node modules, it takes them longer to cold start. That just seems silly. If I were like streaming a Docker container or had it like all bundled, I would want it to be like O bytes, not O files or something like that. And if you ask me, Docker has this same problem, right? Like they don't want Docker container start time to be proportional to the size of the file system in files. They want it to be in terms of the image pull and the download and fancy streaming stuff even to mitigate that. So another fun feature of Overlay is the ability to use multiple lowers. I did not know this existed until like a week ago. But instead of just saying I have one lower dir that I want to shadow and one upper dir, you can list as many lowers as you want. or sorry, that's not actually true. You can hit the kernel struct limit of the length of the mount command, which was actually a huge problem up until a few years ago when they like made it arbitrary length. But anyways, you can add a lot of lower durs, and then that allows you to kind of build a custom mapping of like where to mount a bunch of individual lower durs into the output overlay file system. So this is literally the last slide because I ran out of time and had to come here to give the presentation. So I don't have the like diagram of how it would work exactly, but the idea is instead of kind of mounting one thing in here, what we would do is we would say this low-dash folder corresponds to cache entry dead beef. So that's like one lower dir. This Urkel desirable node module responds to good food. And we'd like construct this ungodly long overlay mount like command and O1 the whole file system into existence. No ref linking step at all, just presenting the kind of thing as we want it, and then probably like the 100 extra unique files I mentioned like getting written off to the side. So that's what I'm hoping we can pull together, but yeah, I can't even tell you if it's gonna work. So and I think that's it. Thanks for listening. I would love to take some questions and or commentary and or feedback, but I just want to make a quick shout out. I worked pretty hard on Daylogger, but the main architect of it is this guy named Alex, who I know a bunch of you guys know. I want to give a big shout out to him because it's his baby and he did great. Yeah. So, what do you think? What Harry do? How fix? Idiot.
How big is your team?
3-ish people working on this.
Plus yourself?
Yeah, and all the rest of the infrastructure.
Does any of you know C?
No.
That's kind of it, because you can just fork overlayfs, right?
Can and should are different words.
Yeah.
Why not?
That's
Because you would just solve all your problems.
Yeah.
I don't.
Because you just do whatever you want in that layer.
Trying really hard to stay on a normal-ish Google deployment.
But the thing is then, like, you end up, like, with, like, let's say if you do your work there, right? And then you end up hitting, I don't know, some godly limit, right? Like, it's clearly not designed for this purpose. You would just find something that no one has ever tested.
Can you repeat the way you said fork? What's right?
Fork
Overlayfs.
Yeah.
I mean, you can also write your own. You don't have to fork it.
That's actually
There's
what I
AI.
Can you
right?
just inject enough logic into overlay FS with the VPS?
I don't think you need. That's where I'm.
No, probably not. Because you can't write usually in UPF. You can only read.
That's
You can, but it gets big O of scary when you have more layers. Big O of scary is a really good time complexity.
Would you want to say, JJ?
Yeah, my hot take here is that you need to write your own file system. Like, you're 19% there. I've seen 10-line tutorials in Rust. Access is the layer that you spent the whole talk talking about.
Totally.
And you're swimming against the river with overlayfs.
I think so too.
And moreover, once people start actually writing into those files, is when you're actually going to start caring even more.
That's true. Though I am okay with slower writes because it's development scale writes.
No, but it's
You
to
know.
guarantee the safety.
Yeah. So I think what I'm trying to do is resist like a fuse. You know what I mean?
But like a overlayfs custom is just like a module you load in. It's not even a custom kernel. You just like end up loading a module in.
Yeah, user
I guess
space.
if I-
You can have
if I
user
rename
space.
it. Right.
Yeah, exactly. You rename it, call it Harry FS.
Sick.
That's free advice. Take it as you will. Just throw it in the garbage can.
Yeah. So I did a bunch of research on high performance fuse, and like it adds
Not worth it.
Yeah.
Just don't even try.
It adds a lot of overhead per metadata call, and there's like a way to do zero copy stuff, but it's really hard, and you can't even actually get everything, and it requires like modern kernel
Just
features.
fork. Just copy paste the code.
That's terrifying. You're so
You
ambitious.
should just like
There's AI, right? It's not
Vibe coding the
Yeah.
file system?
No, it's like you don't need that much. Like you just said you have an ON link. Just put that in the FS.
Oh god, okay. Noted.
Think about it.
Imagine you're a file system programmer who hasn't loaded their files.
The other thing you might want to look at is containerd uses device mapper in snapshots, which essentially is copy on write snapshots for a block device.
Oh,
So you can make a block device and essentially attach another block device that takes the copy on write snapshots at the block layer.
Right.
So I'm going to go into details later. I actually built something very similar to this, except
Yeah.
for an entirely different reason. At Stripe for doing CI builds. We sandbox all of our CI builds in Firecracker now.
Right.
But we hit the two-measure VFS thing as well and just like bounce off of it hard enough that we stopped using it.
Right.
And the thing we ended up doing is mounting a read-only cache as a read-only block device into the VM, creating a thin pool snapshot in the VM.
Right.
And all the writes go to that, which gets thrown away at the end of the action.
That makes so much sense.
And
How do you
then
prepare the snapshots?
we did the same thing. The
Right.
modules just got stuck in the snapshot, private stuff, we copied it, and post hoc. And it ended up being like more than one block device, and a lot of
Right.
details are kind of hand-wavy.
Right.
And the particular thing is
Interesting.
ref links work properly because ref links update the inode, but not the data blocks.
Right.
So ref link is really fast. It doesn't
Right.
update the data as well.
Right.
Ref link, you end up just having a bunch of that, and then you keep the block device that's the write block device on templates.
Right.
Because you just throw it away.
Persistent schmersistence.
Yeah, exactly. So you have a template block device that takes the writes.
That's so smart.
It's Containerd is open source, and their device mapper snapshotter thing is all ingoing.
Dope. Super dope.
The downside is you have to deal with block devices as opposed to directories.
Yeah.
And it's kind of a pain in the ass.
Yes, that sounds like it. Yeah. What file system was it?
XFS.
Right.
We TimeButterFS was not good.
Yeah.
Not sure it is now, but it certainly wasn't then.
Yeah.
So XFS is reference.
Bcache.
FS without compression?
You can. I've never tried that though.
That would be ridiculous.
Yeah, I think we ended up, someone after I left ended up looking at that, and I don't know what the outcome was, but there's a blog post. Look at the strike blog post for Bazel CI runners, something. And they mentioned this.
Right.
But yeah, copy and write block devices also work here. You also don't have to write your own file system, which is I'm like a security
No,
person,
no.
I'm all conservative and shit.
No,
Yeah.
you don't need to write your own file system. The overlayfs right there. You just need to
Yeah.
change like 20
I guess-
lines with AI.
Write is a software. You don't have to modify a file system, which I'm a security person, I'm scared as a profession, so like, don't take my word for it.
Totally. I want to call it one other thing too, is that if you end up having this problem in the future, this one's open source. So if you do want to use it, go snag it.
Yeah, open source.
Alright, I think this is a great discussion, but we have to stop because we're gonna lose access to this room. So
Get out.
thank you for coming, everyone, and thanks to Z and Harry for the presentations.
Thanks for coming, everybody.